Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to be talking about Eloquent JavaScript. Moving ahead to Chapter 4, all about data structures, arrays, objects, lots of fun stuff in this video. If you guys remember last time, we talked a lot about functions, pretty much all about functions. I don't want to go too much into depth with what we did last time. Not that I do like a super in-depth summary, but we got a lot to cover today. I want to try to do this all within an hour, so I suggest we just kick things off. Let's get started. Let's kick the fun off. We'll go to the next slide here. Don't mind the code on the left. Oh yeah, we're using REPL today, repel. Today instead of CodePen. Remember all those issues we had with CodePen? Hopefully we don't have it with REPL, however you say it. But okay, data structure. So simple data types. If you come from Java World, in Java World there are 8 primitive types. I think there's 8. So there's ints, there's doubles, there's floats, there's bytes, shorts, longs. Am I missing one? 6. I counted 6 there. Strings are objects. It's not a primitive type. Booleans, I don't believe booleans are a primitive type either. They mainly have to do with numbers. In JavaScript, we have numbers, booleans, and strings. They're all kind of treated as like a similar type, in which I remember somebody told me this and it's always stuck in my head. In JavaScript, everything is an object. So that's automatically like what my mind thinks about. Everything's an object in JavaScript. So that's where my mind goes. Slightly different from Java. So what are data structures? Data structures are built from these types. Data structures allow you to store information and have better access to it. So what's an example of a data structure? An array. Okay, so an array is, there we go, that's the next slide here. An array, I'm just going to comment out this stuff. It may not work with some, I'm not even on an Android, you duggo. There we go. Okay. So an array, how do you write an array in JavaScript? Well, let's have a binding here. And right now it's an empty array. All right. So anything in between the square brackets is an array. An array is a list of values between square brackets. Each value / piece of data is separated by a comma. So if I wanted to fill this array with some values, some elements, maybe we can do strings. So we got a string first, we got a string second, and so this is what it prints. Console.logs out first at the first index, and then string at the second index. It's 0-based counting, so the first index is the 0 index, and then the next one is 1, and then so on and so forth. So just remember that for arrays, it's 1 less. So first element here is a 0 index. Just remember it's 0-based counting. So what would be the length of this array? The length of it, or the size of it, is 2. In our case here, there's 2 elements in it, so the length is 2. And what is the last index of this array? Again, think about the 0-based index. It would be 1. So length is 2, but the last index is 1. This comes in handy when you're looping, right? Because the part of the loop where it's the Boolean check, right? You are checking to see if you've reached the end of the array. Else, if If you go beyond the scope of the array, then you get, I think it's like an array index out of bounds exception that I've seen in Java. So just think about this when looping. You want to go one less than the length, right? Or you want to go until you equal, until you're greater than the length. How about that? Just two different ways to write it. But anyway, let's just keep it moving forward. Again, lots to cover here. What do we got here? Data sets, and then we got properties. Okay. Properties. And we're gonna talk more about arrays a little bit later. So don't fret, guys. Actually, I want to test one thing because in JavaScript, let's see if this works. Yeah, see, in JavaScript, you can have numbers. Your arrays don't have to be of a type. Like in Java, when you define an array or an array list, everything in that list has to be of the same type. But in JavaScript, doesn't have to be so. I mean, look at here. You've got two strings, and then you've got a number here. And this works in JavaScript. It's pretty cool, in my opinion. And this, again, comes in handy for a lot of different things that you can do. So what are properties? So properties, things that are accessed to possess certain information about a value. So they can be accessed by dot notation or square brackets. So properties are like length is a property. Length is a property. So if I were to do x dot length, this prints out 3. Now, is that correct? Look at the array that we assigned to x here. 1, 2, 3. Last index is at 2, right? So the last index plus 1, that's the length. So this is correct. X dot length is 3. Length is the property. All right, and you access it by this one of two ways. This dot notation, right? So it goes and retrieves the value. Because I like to think of like properties have like a key value pair. So the length is the name, and then the value is like the value that's stored for the length, which in this case is 3. So how else can we access properties? Well, we can do it via bracket notation. So I wonder if this would do the same thing. This does the same thing. Okay. But it's slightly different. So if the dot notation is the literal name of the property, square bracket notation means the expression length is evaluated and the result is converted to a string to get the property name. So this string is evaluated to get the property name length. Okay. This, I'm going to do another example of this when we talk about objects. I usually always use the dot notation. It just comes across as way more intuitive, I think. But you won't be able to use dot notation on everything, as Marjan talks about in this chapter. So there are rules like in regards to binding names where you can't use special keywords, you can't start with a digit, etc. So you can't have a property that starts with a digit, that has a keyword in it. So this, for example, like x.to, you can't do that. You couldn't have a property, assign a property. Oh, I'm about to sneeze. Bless me. You can't assign a value to a property name of 2. I hope I'm saying that right. But you could do the square brackets, I guess, and have a property 2. So 2 gets a value. 2 is the expression. 2 gets evaluated, and the result is converted to a string to get the property name. Okay. I'm going to test this out later when we talk about objects, but that's properties. 2 different ways to access it. Square brackets or dots. Let's continue to the next slide. Methods. So properties that contain functions are called methods. Okay, so before, like x.length, that contains values, but properties that contain functions are called methods. So for example, sample string dot to uppercase. So let's try this out. So to uppercase is going to take every character of that string and then convert it into an uppercase character. So I normally would define, declare and initialize a variable that and assign it to a string, or declare a variable and then initialize it with the string. Got to get my wording right. I know it's like a word salad sometimes with this coding stuff. But we already have a string. We already have a string at the first index of x. How can we access this? Well, you access it kind of in a similar way to Java with square brackets, and I'm going to get rid of this. There we go. So you're telling it, okay, we have an array assigned to x, so go get the first index, which is 0, the 0 index of x, which happens to be first. You can see that on the right-hand side, right? So that is a string. So now we can call the property of this string to uppercase. Now this is interesting. Object function. So to uppercase, without the parentheses, I think we talked about this last time too in our last video. Without the parentheses, it doesn't actually invoke the function. Without the parentheses, it'll just return if it's a function or not. So that's basically what it's doing here. It's telling you, hey, this to uppercase, this is a function. That's like the type that it is. Now, watch what happens when we do use the parentheses. Look at that. We get first, all caps. And I think this is just a way to distinguish that you're invoking the function in case the function had any parameters that you needed to pass in. In the case of to uppercase, I don't believe it does. Like, I don't think it takes any arguments. And even if it did, they wouldn't. Remember, we learned last time with functions that if you pass in any extra parameters to a function in JavaScript, then, and it doesn't need them, it's not going to use them. It's not going to like throw an error or anything like that. Whereas in Java, that is not the case. You need to have the specific, your parameters need to match up with the method signature. So look at, in this case, I'm passing in this JavaScript string. Still printing out first. I'm guessing it didn't even use this. So just something to think about. Let's continue on. Slide 6, objects. Here we go. All right. Objects. Let me comment that out. Objects. So what are objects? Objects are an arbitrary collection of properties. They use brace notation instead of square brackets, and they're key value pairs, and each key value pair is separated by a comma. So think about, it's kind of like an array, except that each element, each key value pair, instead of having like a singular element there, like a string or a number or a Boolean, you have a key value pair here separated by a colon, and then it's basically a list of key value pairs. So let's define an object. Our object x equals square brackets. We are going to have our first property, which is 4, and then our second property, which is 5, let's say. Okay. If you call a property of an object that doesn't exist, you get undefined, call via dot notation. So this is kind of where I wanted to test this out. Okay, so what if we wanted to get the value of the property first. Well, let's use dot notation. Object X dot first 22 and 12. Why is this giving? Oh, I'm sorry, guys. I didn't assign it. There we go. Okay. There we go. I was getting worried there for a second. Okay, so object X dot first. What does this return? This returns 4, right? So it gets the property name first, and then returns the value for it, 4. So we could also do this via square brackets. Object, remember, this won't do anything. That won't do anything. It's got to, whenever you see the square brackets for accessing a property, inside the square brackets, it has to evaluate to something. So this string, so first here, now this should produce 4. If I got the object name right, there we go. So 4. Do you guys see that? What I am wondering, let's do this. Let's add another property here. Let's call it 3. And let's say a string here. Okay. Now, are we going to be able to call this? No, I don't believe we are. See, look at that. We got an unexpected token. And we try to call that. Because again, it's got kind of similar rules to bindings. Again, a binding name can't start with a number, can't be a keyword, reserved word. So in order to call this, we've got to call it with the square brackets. And we've got to do something like this. Now, there we go. So now it returns 3. And that's the value at this property, 3. Right? So the 3 in the string, it had to evaluate it. Let me take a look at this definition. The expression X. So the expression 3 is evaluated and the result is converted to a string to get the property name. Okay. So this is going to come in handy if you do have properties that start with like a number. You know, say you'll have to use the square bracket notation and you won't be able to use the dot notation. Let's continue forward. Unary operators for an object. So we have some here listed: delete, in, object.keys, object.assign. Let's use these on our object here, object X. So delete. When used, property will no longer be present. So I'm wondering how to use delete object X dot first. Let's see what happens. Does not allow the use of delete yet. Okay, well that's good to know. But normally, let me see if I can find an example in Mergen. Here we go. The delete operator cuts off a tentacle from such an octopus. It is a unary operator that when applied to an object property will remove the name property from the object, so you guys can see how it works here. Delete and then the property accessed via dot notation. And then when you try to print off the value, you get undefined because it deleted it. Next is this in operator, which returns a Boolean if the object has that particular property name. I wonder if repel has this. So left in an object. So let's try this. Let's try first. So does it have a property named first in object X? Well, yes, I do know that. Here, we'll delete that. Let's see what happens. True. Oh, okay, so it does have the end. So true. Does it have... Is the property name second in object X? True. How about this? How about... is this in object X? False, it's not. It's not there. So that's kind of pretty handy. You can check to see if a certain property is in an object by using the in keyword. And this kind of actually just made me think about something else. Another instance where you would have to use dot notation is, what if you had a property like this? Is this with a space there, right? Because this would be legal. I am fairly certain. Okay, this is a keyword. Is it? Let's do that. Is it 7? Oops. I'm just trying to work through the... Okay. So yeah, that works. Is it 7? Notice the space there. This is legal. It's printing, as you can see in the console there. So we have a property, is it. The value is 7. You're not going to be able to use dot notation here, guys. So object X dot is it. You're not going to be able to. There's a space here. So in this case, you would have to... I didn't want to do that. In this case, you're going to have to use square brackets. So you're going to have this string evaluate is it. Oop, and there you can see it there. So just another scenario where you would have to use square bracket notation in getting the property value. Okay, use object.keys to find the properties an object has. So let's see. So you literally call this by object.keys. So object, so this is kind of like calling like math.random. So the object, the keys method from it, this is going to take in an object, and this should print off all of our property, just the names. So it returns, look at that, an array of just the property names. When we print off the object, it returns the key value pairs. See there, 3, 3, first, 4. Can I go? Oh, there we go. 3, 3, first, 4, second, 5. You can see that. Object.keys just returns the property names. Okay. Object.assign is a method where you can copy all the properties from one object into another. Okay, so let's define let new object equal an empty object here. And now let's copy everything from object X into new object. I think, let me see, because I think the way you do this is, yes, okay, first parameter, second parameter is the object that you want. First object is what you're copying. The second object is what you want to put in the first. The first parameter is what you want copied into. The second parameter is the stuff you want to copy. Hopefully that just made sense. But here, I'll show you guys. Okay, so we want to copy into new object because it's empty right now. We want to copy everything from object X. So what does this return? This returns, okay, it returns a new object, basically copied over. So if we do this, guys, so if we do new object dot first, what should this return? It returns 4. Same thing as when we did object X dot first, 4. You can see that there. And actually here, just for better clarity's sake, because it's kind of getting jumbled up, we'll print them off side by side here. There you go, 4 and 4 side by side. Are these two objects equal? Is object X equal to new object? It's kind of interesting, right? How could we check this? How did we check this before? With, let's say, strings. What did we use? We used double equals or triple equals. And do you guys remember the difference? With double equals, there's type coercion. So JavaScript will change the type of one side of the double equals if they don't equal each other. Triple equals checks for precisely the same value, so there's no type change. So in this case, let's try both, because I'm kind of curious to see what happens here. Interesting, it's false. Object X does not equal new object, but we just copied everything over. Interesting. Okay. What if we do triple equals? Does anything change? Nothing changes. It's still false. Okay. I think the reason that it does this is that you're basically taking the properties and copying them into the new object. Doesn't mean that the objects are equal. So let's think about this like cloning. What if you cloned new object from object X? All right. Essentially here what we did is we have kind of like a factory. A factory that's creating models. We have a model and then we're creating copies of that model, right? So they're not exactly the same. They might contain the same ingredients. Like if I have, I'm producing like cookies, right? We have like a master recipe. And that master recipe is going to make a bunch of cookies. They're all going to have the same ingredients in them, same nutritional facts, for the most part, maybe give or take a few calories here and there, but just for the purpose of this thought experiment, everything's going to be the same, right? But not all the cookies are, they're not the same. They contain the same stuff, but each cookie is separate. You got cookie 1, cookie 2, cookie 3, cookie 4, cookie 1,000, depending on how big your operation is. So how would we get these two objects to equal? I want to try something here. Let's let new object 2 equal object X. Fair? Now I want you guys to try this. New object 2. So we took a new object 2 and then we assigned it to object X. New object 2 equals object X. What is this going to return? What's it going to return, guys? What do you... Oops, I'm sorry, guys. Double equals. What do you think it's going to return? True. So before... Remember this one, double equals, returned false. This is the one that we just assigned the properties. This one, we're actually assigning it to object X. So the reference, it's referencing object X. Essentially, it's like a clone of it. So because of that, let's get crazy here. I know I'm kind of going off script here, but this is important. I think we were going to talk about this anyway in the slides, so no big deal. Object X. I want to add a property here. How do we add a property? I believe we can just do this. Object X dot, let's add a new property 4th equals another property. Is that legal? That is legal. So now, if I print object X, what should this give me? It gives me the properties, and look at that. Fourth, we assigned a new property. Fourth is the property name. Value, another property. Because we did this, new object 2, or excuse me, sorry. Because we did this, line 42, new object 2 is being assigned to object X. Is this going to be legal, guys? Is this going to be legal? What do you think? Yes or no? It is legal. So if we do this, right, that's going to print that's going to print the object, and look at that. Fourth is in new object 2. The fourth property that we assigned to object X is in new object 2. Why is that? Because new object 2 contains it references object X. Anything you do to object X is going to happen to new object 2 because they're assigned to each other. This wouldn't happen when you use this assign method because you're just assigning the properties from it, but it doesn't reference object X, right? So if I did this, fifth equals fifth, and then I did this, new object dot fifth. Is this going to do anything? I know I have so much stuff here. I'm getting lost. But I think it's right here. Yeah, there we go. Dot first, new object dot fifth, new object dot first. I think that's, oh man, I'm getting so lost. I have too much stuff here, but this, I don't believe that would work. I do not believe so. Here, we're going to delete some of these because we're getting in the weeds here. We'll delete this. There we go. First, okay, yeah, so it's printing an undefined, right? Because it doesn't contain a reference to it. You copied all the properties prior to assigning this fifth. Now, if you assigned this property fifth above here, so let's take this and let's put that there. Now you see that you get it. New object dot fifth is printing out fifth, right? Which is a part of object X. And then you assign it here. So I know we kind of got in the weeds there a little bit, but important stuff for you guys to know. All about mutability. We kind of were going over that a little bit here. Mutability. Let me delete this. Let me delete this stuff for you guys. You know what? Let me just delete this whole thing. There we go. Mutability. So what does mutability mean? Change. You can change something. Numbers, strings, booleans are all immutable. You can't change the values of those types. The text in between the quotes can't be modified. That's basically what that means. But it can be reassigned. So this is kind of where I got confused with mutability. This is allowed. X equals... This is allowed. You're reassigning it. What it means by immutable, you can't change the contents of this string. You can't remove the I here. I mean, I know I just did there, but down here you couldn't alter the value of this string. That's immutability. Now with objects are mutable. You can change their properties, right? As you kind of saw from the previous examples, you can change their properties. So comparing objects and comparing other types. When you compare objects, comparison by identity. You guys saw this in the last example with the double equals. Have to be precisely the same value. Does not matter that they have the same properties. You guys saw that with the assign. You saw object X and new object had the same properties, but they were not the same object. They had the same properties, but they were not the same object. Object X compared to new object 2, they were the same object because you're assigning object X to new object 2. And I'm sorry, I'm lots of word salad at you there, but this is literally the previous code that we had on the screen was this. So objects are mutable. You can change their properties. We saw that. Did we see that? We did see that on the previous example. We added properties. So you can change objects. You can remove properties or you can add properties. So you are changing the object in that regard. Okay. We saw that the delete operator didn't work. That's okay, but you saw me add a couple new properties there. Really quick. Const versus let. For const, so these are ways of doing bindings. You've seen me use let a lot. What is const? So const, from the Mozilla documentation, constants are block scoped, much like variables. They're declared, much like variables that are declared using the let keyword. The value of a constant can't be changed through reassignment, and it can't be redeclared. So if I did this, const x equals 5. Look at this. I'm getting a type error. Assignment to a constant variable. So you can't reassign it. That's why I like using let, because with let, you can reassign things. With let, from the Mozilla documentation here, let allows you to declare variables that are limited to the scope of a block statement or expression on which it is used. So that's kind of the difference here between const and let. It's kind of why I use let a lot, at least just for these examples. You can use, I use let a lot in for loops when like your incrementer is changing. You know, when we wrote these for loops, guys, if you remember, we did let I equals 0 for the incrementer, and then you have your Boolean check here, and then you have your updater here. We use let here because this I is going to be constantly reassigned. Think about if you use const here, you wouldn't be able to reassign this I. You wouldn't really be able to loop. So anyway, that's just a really quick heads up on the difference between those. Events and squirrel. What was I doing on this slide? Events and squirrel. Objects with just a property name will have the value populated from the binding with the same name. Take a look at the example. Let's take a look at the example. This was the example. That was not the example. Mutability. This was the example. Add entry, journal.push events, and then squirrel. Add entry, So what it's saying here, I'm going to try to reproduce this for you guys. Let's bring this in here. Journal.push, events, and squirrel. So let's call this function. It's going to take an events, which is an array. So let's do first event, and then let's do second event, and then let's do third event. Whose squirrel is this? The squirrel is John, let's say. Okay. Add entry for a second. Undefined variable John. Oh, I'm so sorry, guys. String. Undefined. False. Oh, it's a Boolean? Does it have to be a Boolean? That's okay. And let's print journal. What does this do? Events. Oh, okay. Okay. I'm sorry, guys. So objects with just a property name will have the value populated from the binding with the same name. Objects with just the property name will have the value populated from the binding with the same name. I'm trying to understand what they mean. Oh, because look at, okay. See, guys, look, even I'm learning here. So we've got this journal, right? It's assigned to an empty array, right? We have a function. This function is called add entry. It's taking in two parameters, events and squirrel. We are then taking events and squirrel, and then we are pushing them. This is an array method. This pushes the value that you pass into the, I think it's the last element, to the last spot in your array, to the end of the array. And then I believe shift and unshift have to do with the beginning of the array. I got a slide on this. We're going to talk about it. So look at what you're doing here. You're pushing an object, but you don't have properties. You don't have the colon here, right? You don't have the colon here. So what it's saying, if you just have the property name, the value with just a property name will have the value populated from the binding with the same name. So the property name here is going to be events. The value is going to be the variable that you pass in here, whatever this contains. Whatever that contains. In the example from Eloquent JavaScript, they're passing in an array. But, and as you can see there, so you have an events property, the array, squirrel property, and then the Boolean, right? And what's the parameters called here? Events and squirrel. Think about it. This is events. This is going to be the value assigned to the events property. This is going to be the value assigned to the squirrel property. But this doesn't have to be a Boolean here, guys. And this is where I kind of messed up here. This could be John, and this could be a number. This could be 4. You know, and look what you have here. Events for squirrel John. It's just assigned. The values in the parameters don't matter. The names are the same here. So it's going to infer that the events property is going to contain the events values that are passed in. Hopefully I'm making sense here, guys. But I thought this was actually kind of cool. I don't think I've seen anything like this in Java. So I thought that was kind of cool. Array loops, a different way to loop in an array. Classic ways to use the initializer, Boolean, check, and the updater. You guys just saw me, write a little quick loop there, but you can also use this of keyword, and it's similar to an enhanced for loop in Java, where it's basically you're looping for every element of this list. So you don't have the incrementer, you don't have the Boolean check, and you don't have the decrementer. It's like a really nice and succinct way to write a loop in Java. Let me go back here. So we got first, second, third. Then we got John. We got this journal. So we got a journal array, right? Got this journal array. Yeah, okay. Sorry. We do got the journal array. Let me do another array here. 1, 2, 3, 4. Because I'm going to show you guys how to loop through this. Of keywords. So of journal. So every number of journal. What does this do? I got a bad feeling. This doesn't really do much. Number of journal. Use of. Similar to enhanced for loop. Number. How did we do this? Computing correlation. Let entry of. Oh. Okay. There we go. I'm so silly. So you still use the for loop. So you let each number of, what's our array name? Sample array. And number. And will this do anything? Did I write this the correct way? Let entry of journal. I did. I don't think this is something that you console.log though. Oh my gosh, guys. I forgot the assignment. There we go. Okay. Let entry console.log entry undefined. What if I did that? For let entry of sample array. The word of after it will loop the elements of the value given after of. This works not only for arrays, but also for strings and other data structures. Okay, so this is basically a different way of doing that initializer, updater, Boolean check. So you're saying for each entry of sample array, let's do entry plus 1. Oops. And then let's print sample array again. Oh, right. Entry plus 1. What happens if I do this? Return entry plus 1. Oh, shoot. Yeah, you can't. Darn it. I want to show you guys this. 4 and 5. Entry plus 1. Sample array. Sample array. Well, that's not going to work. This won't work. I'm trying to show you guys that this like can loop through here. I don't think this is going to work. Yeah, that's not going to work. That's not working either. Oh my gosh. Anyway, this is how you would loop through. How you would loop through. And I wonder all right. I'm going for broke here, guys. I just want to show you that this is actually looping through. Function actually looping. It's going to take in sample array. Alrighty. Going for broke here. And then please return entry. All right, I probably shouldn't entry. Plus plus. Return entry. This isn't going to do it either. Yeah. Actually looping, let's pass in sample array. Four and 4, undefined variable entry. Let entry of sample array. Undefined. Oh my gosh. Whoa, I went for broke, guys, and it didn't work. Return entry. Oh, thank you so much. Right, it returns it, but it returns it. That's why you only get the first index here. Anyway, guys, this is just a different way to loop. Trust me on this. It loops through each entry, and this could be whatever arbitrary name, you could call it like name. And you could say here name, it'll still return 1, right? Now return exits the loop, exits the function, so that's why you only see a 1 here, because first entry, return name, and it's just going to return that first index there. So anyways, I'm sorry guys for taking up so much time. Let's continue forward. Arrays also have an includes method that checks if a value is in an array. So let's try it here. Sample array dot includes 1. False. It doesn't. It returns a Boolean because it's going to check the array at each element to see if it includes this string. And you can pass in numbers here too. So what if I do 1? Returns true because 1 is in sample array, right? Let's continue. Other array methods. Here we go. Push, pop, shift, unshift, index of. Let's try index of really quick because this will return the index at which that element is in the array. So where is 1 in sample array? It's at the first index, right? Which is the 0 index. That's what this returns. Now, what happens if an element is not in your array, like 5? Returns -1. So this is something that you can use in looping to check. This could be like a Boolean check to see if something's in your array. Like you could do an if statement. If array.index of I, does not equal -1, then you know that that element is in your array. Else if it did equal -1, then you know that it's not in your array. But we also have other methods here. Push and pop. So let's do sample array dot push. Let's push 5. So it returns 5, and then what happens if we print sample array? And as you can see, it adds 5 to the end. What if we did pop? So we pop off 5. What if we did... Let me comment that out. What if we did this? So we got 4. Okay. And I want to pop removes an element from the and returns that value. So I want to remove 4, which it already kind of did there. Return 4, and then that I want to remove removes an element from the end of the array. Oh, okay. I'm sorry. So this, I don't think that this returns anything. Or excuse me, I don't think this takes in a parameter. It just pops off the last element of the array. Right? Because what if I did this again? Would it pop off 3? It did. So now we just have 1 and 2 there. You can see, so the first pop pops off the 4. The second pop pops off the 3, returns the 3. So what's left of the array? Just 1 and 2 because you did pops. Shift and unshift. Shift removes the first element from an array and returns that value. So let's see here. Instead of those... So we got our array 1, 2, 3, 4. What if we did shift and unshift? So shift removes. So remove the 1. You can see that here, guys. Unshift adds 1 or more elements to the beginning of the array and returns the new length of the array. So unshift. Let's unshift and let's put 0 at the beginning of the array. Look at that. Put 0. Let's put -1 at the beginning of the array. Look at. Oh, that's funny. So you would have to put this. You would have to put this here. There we go. So it adds -1 to the beginning, and then the next one after the beginning, it adds the 0. And you can pass in however many params here you want to add to the beginning of the array. But remember, it starts off from this end, adds this to the beginning, and then adds this at the index directly after the beginning. And then if you were to do another element here, like let's say 45, so it would add it after the 0, but before the 1. Okay. Next, oh my gosh, more. We got last index of, slice, and concat. All right. Let me delete these. Go back. So we got 1, 2, 3, 4. Last index of starts at the end of the array and searches for the last occurrence of an element. Last index of an element. So sample array dot last index of, and then let's say the last index of 5 returns -1 because 5 isn't in our array. Remember, we're working off of this now. This 1, 2, 3, 4. What is the last index of 4? Think about it, guys. What's the last index of 4? If you said 3, you're correct. The length of the array, sample array, is 4, but the last index of 4 occurs at the third index, or at the very end. So that's last index of. It also takes in an optional second argument, I guess. Indicates where to start searching. So I wonder, like, if I tell it, hey, start searching at 3, it still returns 3. What if I tell it start searching at 2? You get a -1. So you're telling it to start here. It starts at the end and works its way backwards, so it doesn't find 4 here. If you do 3, like I said, it starts at the end, goes all the way back, and 4 is indeed at the very last index there. Slice takes in 2 arguments, a start and an end. Returns an array of the elements between the 2 arguments, start and end. So if I wanted to just take a slice of this array, like a slice of pie, right? Slice of pie. So I want to get the first 2 elements. I want to make a new array that's just the first 2 elements, 1 and 2. What can I do? I can take a slice of it. First index is inclusive, so I want to take everything from the 0. Second parameter here is where your slice goes to, and it's exclusive. It excludes it. So I want everything starting at 0, including 0, going up to 2, but not including 2. So basically 0 and 1. And as you can see there, it takes in the 1 and 2. If you don't supply any arguments to the method, it copies the whole array. So if I just did this, .slice, it should return, yep, the whole array, just 1, 2, 3, 4. Concat, used to combine arrays together to create a new array. Values from the other array are added to the end of the calling array. Pretty cool. So, let's do this. Let's concat sample array and second array. What do we have? 1, 2, 3, 4. 1, 2, 3, 4. Oh, man. Sample array 1, 2, 3, 4. I'm going to get rid of that. 1, 2, 3, 4. 1, 2, 3, 4. 5, 6, 7, 8. 5, 6, 7, 8. Okay. So this just concatenated a second array to sample array. I don't know why it did it twice, though. You can pass in values to the method, and they will be added to the end. You can passing in multiple arrays, and they will be added to the end of the calling array in order that they all appear in the method signature. Okay. And then you don't have to pass in arrays here. You can actually, I'm pretty sure, do this too. And this will just concatenate it to the very end. Yeah, so after the end of the second array, it adds that element to it too. So that's pretty cool. That's concatenating. Same thing like concatenating strings. You're combining arrays. And it takes in an arbitrary amount of arguments that you want to concatenate together. Oh, I know why it does this now, because you're calling sample array.concat. So you're concatenating sample array to sample array, and then you're concatenating second array. So this now, yep, 1, 2, 3, 4, 5, 6, 7, 8, and then this. Can you guys see there? Because concat is a method. You're calling it on sample array, and you're concatenating second array plus this, the string this. And before I had sample array as the first param here. So, you know, it looked like this. So, oops, I'm sorry. Like this. So that's why I was getting 1, 2, 3, 4, 1, 2, 3, 4 concatenated twice. Whoa! Let's continue forward. Strings and their properties. Let me take a swig of water. Strings and their properties. So arrays have properties, but so do strings. You can't store new properties on strings, though. Much like we did on objects, where we created new properties on an object. But with strings, you can't really do that. Same with numbers, same with booleans. But strings have some properties. So strings like let x equal string. So there's a length property that you can use. So you could say x.length. This is going to return 6. string, that's 6 characters. You saw the 2 uppercase being used. It's got similar methods, so it's got an index of method. So you could do index of, if you do 5 here, it's going to return -1. 5 is not in there. But if you do t, it won't return anything, because t has to be in double quotes, and you can see there it's at the first index, same as arrays, 0-based counting. So s is at the 0 index. Excuse me, t is at the first index, r is at the second, and so on and so forth. There is a trim method. That will return the string minus any extra white spaces from the start and end of the string. So there I got a white space. At the end I got a white space. X.trim returns string without the white spaces. It would also, you know, return any of this stuff, the new line stuff, like that. / or was it backslash? I don't think it was backslash. Yeah, I don't believe it was that. Okay. And notice there, guys, it did not reduce the white space in between the string and the /n. It just trims off the white space from the front and the start and the finish of it. Pad start takes in. Can I? Thank you. I'm sure you guys are like, hey, can you zoom in? There we go. Pad start takes in the desired length and padding character as arguments. We'll add padding characters to the string until its length equals the arguments passed in. So let's take this back. Let num equal 6. Let's say num dot pad start, desired length and padding characters as arguments. So what's the desired length? We want a 3-digit number here, so let's do 3. What do we want to pad to make that 3 a length of 3? We want to add 0. So the second argument is what you want to pad it with. The first argument, 3, is the length at which you want the padding to be added to. Or excuse me, the amount of padding to add to reach that length. Right? So am I saying that correctly? You want a string with a length of 3, and this is the thing that you want to pad to get to 3. So as you can see, there's 006. Length of 3, you got to add 2 zeros to it. Right? If I did 4 here, it's going to add another 0. Right? Moving right along, we got split, we got join, we got repeat. And you can also access characters of a string using the same square brackets like you do for arrays. So let's use this. So second index returns an R, right? That makes sense. That's right there, R. Splits a string into an array on every occurrence of a string argument. So, let's say string 2, string 3. You had this string, right? And now I want to split x dot split, and we want to split it on each space here. This is going to return an array, string 2, string 3. Oh, yeah, look at that, guys. So it splits it at each white space character, at each space here. So space. So we've got string 2, string, and then 3. That's what it returns. Similarly, you can join, returns a string by concatenating all the elements of an array together. The elements will be separated by a string separator argument. All right. So we could say this, let array equal that, right? And then we could say array.join a separator. The separator is going to be that. What does that return? A string with commas at each of the spaces. Essentially, the commas are going to represent separating each element of the array. That's the argument that the join takes in. This is the separator. So splits up a string at a specified param, splits it into an array, and then joins an array into a string, two opposites. Then you got this repeat method, which creates a new string with multiple copies. So x dot repeat what do I do this? Yeah, so it makes 2 copies of that string x. I guess this would be better to show you guys if I did like num, so 6, 2 copies, right? If I change this to 7, 7, yeah. Up next, okay, next slide we got rest parameters. So what are these? So this is the triple dots that you see in a function. So let's make things simple here. Let's say we have an array, right? We have an array 1, 2, 3, 4. And then let's make a function. Oh man, I know it's been a long episode, guys. Let's get through a function add 1. All right, and then this is going to take in sample array. To take in an arbitrary amount of arguments as an array. Okay. And then all we're going to do here, let's say for, and again, did I do this? I did. Okay. For each let x of sample array, and it's, how about this? How about we say sum? And we're going to say sum plus equals x. And then we're going to say we're going to return sum. Okay. I had the array up there on line 1, but tell you what, I'm going to call this function, and this is not a good name for it because I'm returning a sum here. So the spread operator there, those 3 dots, are going to signify this takes in an arbitrary amount of arguments, and it's going to convert it to an array. So if I pass in, 1, 2, 3, 4 here, think about what's happening here. It's taking those numbers, 1, 2, 3, and 4. It's converting them to an array. That's going to allow me to loop through here. And then what am I doing for each x of the sample array? So for each element of the sample array, I'm taking the sum, and then I'm assigning sum to sum plus x. So for the first iteration, it's 0, right? 0 plus, what's the first element here? 1. So essentially what I'm doing here is I'm doing 1 plus 2 plus 3 plus 4, which is equal to what? 10. That's what we get here. Do you guys see how I did that? And you can add, right? This takes in however many arguments, and it'll convert it to an array. So what if I did this, though? I'm curious. What if I did that? Interesting. So that converted. Very interesting. It made it into a string. Wow. That's really interesting. So sum of 0 plus x. What if I did this? Just so we know exactly what it's passing in. 1, 2, 3, 4. Array. That's really interesting. I did not know it was going to do that. Wow. Okay. An array in the function call. So really, this is used for arbitrary amounts of arguments like I had previously, like that. This gets converted into the array. Okay. But Mergen also talks about you can spread an array in the function call. This will pass each argument as separate arguments. I'm not sure why you would want to do this, though. Okay. So what this means, what does this mean? What does this mean? This does not mean this. Nope, that's not what we're doing. Sample array. You can spread the array in the function call. This will pass each element as separate arguments. Mergen had a really is going to explain this a lot better than I do. This is the point that I don't get. So I just showed you guys if you pass in an arbitrary amount of arguments. Oh, and the rest parameter must be the last parameter in the function. So going back. So here, like if I could do this, right? I could do that. However, this would not be legal. This, yeah, you can't do that. Not permitted after the rest element. So if you have multiple params here, the rest param has to be the last element in the method signature. And this will still work the same way. You could still loop through this sample array, but now you have access to this X, right? So if I pass in this 1, 2, 3, 4, 5, 6, let's do this. Let's do X, and then let's do sample array here. Do you see here that X gets assigned to 1, and then the rest parameters take the rest of these arguments? Do you see that? So 2, 3, 4, 5, 6 belong to sample array, while X gets 1. So that's just something to think about. The rest param should always be the last element, the last parameter in the method signature. This spreads out the array into passing its elements as separate arguments. It is possible to include an array like that with other arguments, as in... No, you can use similar 3-dot notation to call a function with an array of arguments. This spreads out the array in the function call, passing its elements as separate arguments. Okay, it is possible to include... Yeah, that's what I'm not getting here, guys, is if I pass in... like I pass in this. Sample... Oops, excuse me. Array. Right, I'm not going to get anything there. Let sum equals 0 as separate arguments. Yeah, I'm not quite sure how to interpret that. So it's essentially taking, it's taking the array and assigning it the first index in a new array. Okay, I get that. Out an array in the function call. Separate arguments. So yeah, I'm not quite sure, to be honest. And again, that's why I put this note here. I'm not sure why you would do this. If somebody has an idea, please let me know. But I kind of thought that if you pass an array into here that's taking in a rest parameter, you're passing in essentially 4 arguments, because there's 4, the length of this is 4. There's 4 elements in this array, but that is not the case. So anyway, let's continue forward. Destructuring. If you know the value you are binding is an array, you can peek inside the value using square brackets and bind its contents. Unpacking array elements into distinct variables works the same in objects, except you use square brackets instead of, curly braces instead of square brackets. Math.object, we're not going over that. So yes, destructuring. Let's go back to the phi function for a moment. This is, yes, this is what they're talking about here. If you know the values you are binding in an array, you can peek the value inside the square brackets and bind its contents. Okay. 1, 2, 3, 4. So basically what this means A, B, C, D. A, B, C, D. So this is destructuring. I know that this is taking an array. Now you're assigning each index of the array a variable, and then you can use those variables. It's essentially you're doing a binding here. Now I'm wondering, what if I did this? Okay, so if I did this, you wouldn't get the D binding. So that's why that's returning undefined, but you still get C, B, and A, which are 1, 2, and 3, right? A, B, and C, the first index, second, and third. First index, second, and third. You guys see that right there? So you're unpacking it. You're unpacking it into these bindings there, so to speak. Hopefully that makes sense. Now it works the same for objects. So let object X equals curly braces first and second. Okay, so now if you want to unpack this, you would say, let me give this another name. Another name equals object X. Oh, I spelled it wrong. Oh my gosh, I spelled it wrong here. Object X. Unexpected token. Because you can do this. Okay. So I got to do this. Let name Faraji. Oh, so I can do this? Let name console log. Well, we know that. Okay, so you have to do like that. Anyway, I'm not sure why this isn't working. Basically, I'm trying to do this. So you're unpacking this name binding, which is here in the object. So you can look inside of the value binding its contents. Yeah, that's weird. I wonder why that didn't work. But you could see that it worked up here. So that's destructuring. Next, JSON. So what is JSON? JSON stands for JavaScript Object Notation. Objects and arrays are stored in a computer's memory as sequences of bits holding addresses of their contents. So they're stored in a place in the computer's memory. That's the place where they're stored. So what about if you wanted to send data to another computer? Well, that would be kind of tough because you just are storing the sequence of bit holding the addresses of their contents, right? So when you store it, that might have issues like going across like a connection to another computer, right? Because you just send them, like the memory space. This is kind of like if you try to print, I remember like in Java, if you tried to print an object, like without a toString method, you would print the object's, like the reference, the memory reference to it, the memory address of it. So how do you send that over? It's going to be kind of tough. I mean, you can maybe send it over, but the other person isn't going to understand what you're sending them. So there's a way to do that. You serialize it using JSON. JSON is one of the ways to do this. So in JSON, you're sending essentially the same thing as an object, except the key value pairs are both in double quotes. You can't use function calls. There's no bindings. Nothing that involves computation. It's just kind of like just a pure string. And also no comments are allowed either. So how do you do this? So let's take a look at an example of a JSON using these two methods here. So we have our object X, right? JSON.stringify. This is going to take a JavaScript value and return a JSON encoded string. Okay, so let JSON is going to be equal to JSON.stringify. And let's do, I am spelling that wrong, object X. What is this going to return? Let JSON.stringify takes a JavaScript value. That's a JavaScript value. It didn't, so what if I do this? This didn't, And this might be just because Repel doesn't have the ability to do this. What if I did this? Oh my gosh, I'm so sorry, guys. This might be why. There we go. There we go. So there is the JSON object. Oh my gosh, and is that why? Anyway, now let's just move forward. So this is what JSON looks like. Look at that. It's a string, so look, there's double quotes at the ends. You have the key value pairs are both in double quotes as well. This is what JSON is. And then this is you're able to send in like HTTP requests, which I'm sure we'll get to that later on in Marijan's book. So this is how you create a JSON object. Now, how do you take a JSON string and convert it back into JavaScript? Let JSON equal. I'm pretty sure that'll still work. Yep. Well, you can do this method that does the reverse. It's called parse. This is going to take a JSON string and convert it back into a JavaScript value. So there's the value. It's kind of hard. This is what it is here. Yeah, and you can see, I know it's got the double quotes for both the key value pair, but you can see there's no quotes around the square brackets like there is for the JSON object. So first there, this is the JSON, and then this is the JavaScript object. Key value pairs, and the keys don't have double quotes around them. So that's what a JSON is. What do we use JSON for again? We're going to use JSON for sending messages across HTTP requests. This is going to be how you can serialize data and send it, package it, and send it off to another computer. So that's JSON. And guys, whew, that concludes our chapter. Chapter 4, data structures. Wow. I'm really sorry, guys, if I sped through this. If you have any questions, please let me know, because I did try to go as quickly as possible. I know this was a long video, lots of topics covered here, lots of methods, lots of cool methods that you can use on both strings and arrays. And if you have any questions, again, let me know in the comments section. If you guys listened this far, wasn't easy. I really appreciate it, guys. And please like and subscribe to the video. We've got more coming out. And we also have launched the blog. So right now I'm blogging on Ted's book. Look out on parenting here. So be on the lookout for some more blog posts. Guys, thank you so much again. I really appreciate it. My name is Chris. This has been Chee-Tash. Take care.